Geometry Enterprise. So now we will start with Emaths, coordinate geometry. It will be part of your WA. Okay, so it's going to be very easy. The formulas are easy, just that the questions you need to think of it. Okay, so we are going to start on the first one. This chapter you need to learn three things: 1, 2, and 3. Length, gradient, and equation. Okay, now we start with length first. Okay, so on this graph paper, right? Okay, we plot lah. A is 4, 3. Okay, so 4, 3 will be somewhere around here lah. Okay, then B is -6, -4. Okay, so now we can plot -6, -4. Okay, C is 4, -4. So it should be somewhere around here. Now, what did you get? So if you join the dots together, okay, you will actually get a right angle triangle, right? This is A, this is B, this is C. So they say find the area lah of this ABC. So this is the right angle triangle. So formula is half times this base times height area. Now first of all, what's the base? So from here to here. So this is from here to here is 6. From here to here is 4. So total is 10. What about the height? From here to here is 4. From here to here is 3. So it's 7. So the total area is 35 square units. Okay. Now, what is the length of AB? So we realize that if it's a horizontal or vertical line, it's easy, right? Just need to add up together. But if it's a straight line, but it's a slanted, okay, it's a slanted straight line. So how? So, but it's a right angle triangle. So you learn in Sec 2 that you can actually use what formula? You can actually use Pythagoras theorem, right? Okay. So Pythagoras theorem, you worked out to be like that. So AB equals to BC squared plus AC squared, right? Okay. So basically it's 10 squared plus 7 squared. So you worked out to be what we worked out to be. It works out to be estimated 12.2. Okay, what's the thing that I want you to learn from here? Length of slanted straight line is actually derived. You can actually construct a right angle triangle and then use Pythagoras theorem. Okay, so the formula, right, will be this. And how they are derived from? Are derived from Pythagoras theorem. Okay, can x1 minus x2. So basically here x1 minus x2 is actually 4 minus -6. So it gives you 10. Okay, and so blah blah blah, things like that. This is the formula. So square root bracket x1 minus x2 bracket square plus bracket y1 minus y2 bracket square. Okay, this is the formula for length of line. So I want you to do question 1, 2, 3, 4. Okay, question 4. Now I'm going to start the first question for you. Now, first and foremost, right? Yeah, we need to lay a strong foundation in your basics first. So you need to be able to identify what's your x1, y1, x2, y2. Okay, so over here, okay, in your mind, you got to tell yourself this x1, y1, x2, y2. Okay, then next step, got to be familiar with the formula. So now it's KL square root, okay, bracket, so x1, right? So -2 minus bracket -7. So now it's a big bracket, okay, square plus, okay, 5 y1 5 minus 6 bracket square. So you realize that if there's a negative, you got to be very careful, big bracket, then minus bracket minus, okay. Continue. negative to negative, positive, negative 2 plus 7, 5. 5 squared, 25. 5 minus 6, negative 1. Negative 1 squared, 1. Square root, 26. Round up to 3SF, answer is 5.10. This is what the working that you should be doing, okay? Either you write it down on pencil or you do it in your mind. I suggest you write down in pencil first lah. And then presentation, if there's a negative sign, put the bracket and outside become big brackets. Okay, this is square outside, here plus. So this is the eyes, nose. Okay, now I'm going to move on to gradient. You learn in this Sec 1 that there are two formulas. Gradient is actually vertical distance over horizontal distance. Just that the plus minus you need to put by yourself. And this is the formula. Y2 minus Y1 over X2 minus X1. Okay, or vice versa. Okay, now by comparing the steepness of the straight line, we can determine which straight line has a greater numerical value for the gradient. So by observation, circle the straight line. Which one has a bigger gradient? So you can see the line A actually is going up, but line B is going down, you know. So this one has a positive gradient, and this one has a negative gradient. So of course this one has a greater one. And what about line C and line D, which is actually steeper? So actually we can tell that line C is steeper. Okay. Moving on. For straight lines. First and foremost, you need to be able to learn in Sec 1 already. You need to be able to, for horizontal lines, be able to indicate their equations. So let's do part 1 first. So this is a horizontal line. This line passes through y equal 4 and it just extends out, right? Okay. So this one we call y equal 4. So this one it passes through y equal 2, right? And you see it just extends y equal 2. So this one is y equal 2. Y equal negative 2. This one you got to know one. So actually the x-axis is it x equals 0 or y equals 0? It's actually y equals 0. Okay. Now what is the numerical value of their gradient? Their gradient are all equal to 0 infinity. 0. Okay. Now what about vertical lines? So vertical line, this one passes through x equal negative 2, right? So, and it just extends throughout one. So this one is x equal negative 2. So what about the y-axis? It is x equal 0. Then x equal 1, x equal 3. So what is the gradient? 0 or infinity? Infinity. Okay. Homework 6, 7. Okay. 6, 7, 8. 8, this one you got to use the rise over run or W. Okay. So you settle these two first, okay. Next recording, I will show you the solutions. Okay. Then I will cover equations of straight line. This is very, very important. You will lay a foundation for your A maths coordinate geometry. Okay. That's it.